I hope if you missed a class, go to the recording of the class so that you're not going to be losing out on the material. There is an SI person who is going to be assigned to this class. When I'll get you her information and her time that she's going to be available. So if you want any help with problems, she's going to be able to do it for you, not only so you can ask me questions, especially I was here since 9:15. You could have asked me any questions or anything you want to talk about. I'm available from 9:15 till 10, both Tuesdays and Thursday. Or if you have a different time that you'd like, just email me and we can either email each other or we can talk on Zoom, etc. Okay, the last thing we were talking about had to do with graphing of linear equations. And we talked about how to graph points on what we call the Cartesian coordinate system. We talked about graphing linear equations, which means taking an equation and drawing the line from that equation. And we also talked about finding two important information about a line, number one being the intercepts of the line, where does the line cross the x and the y axis, and also the slope of the line, how to find the slope of the line from either the equation or from the points. And that's what we had covered on Thursday. Today, we're going to do a little bit of review of some questions, and then I'm going to go on to the next section, which means if I describe a line to you, either I tell you what points are on the line or I give you other information, we're going to be able to then write the equation of the line from this information. So as a quick review, let's do, first of all, this was in the homework, but I don't know if you got to all of them. This was number 4, where, well, let's do number 3. Number 3, where they say find the slope of the line passing through the points 1, -1, and -1, 1. We have 2 points. We want to find the slope of the line between the 2 points. And we said if we have 2 points, we can use the formula for the slope. We call it M. The slope is y2 minus y1 over x2 minus x1. And what we do is, you could either plot it, but you don't even have to draw it. You just call one of your points, let's call this our first point. So if this is our first point, this will be our x1 and our y1. Remember, the x1 means the x of the first point, y1 the y of the first point. Doesn't matter what you call the first point, but as soon as you sign this as x1, then the y of that point has to be the y1. The second point becomes your x2, y2. And therefore, what you're getting is, if I fill in these numbers, y2, which is 1, minus y1, which is minus -1, over x2, which is -1, minus x1, which is 1. I just fill in, I label the numbers, and now I fill them in. And now I have to just finish this up. Don't forget, when you have 2 minuses, it becomes a plus. So this really becomes 1 plus 1, which is 2. And this becomes -1 minus 1, which is -2. So 2 over -2 reduces to -1. When you're asked what the slope is, you can give it as a whole number if it reduces to a whole number. When you want to use it to draw the line, of course, what you want to do is put it as a fraction, because remember what slope is. Slope is rise over run. So if I'm telling you that my slope is -1, it really means -1 over 1, which means to go from one point to another, you rise -1, which means you go down 1, and you go 1 to the right. So that's how you would find the slope of the line if you're given 2 points of the line. Let's do number 7 as a further review. Any question about what I've done so far? No, I did not take attendance. I'll take attendance later in the period. We'll wait until more people are here. Okay, so question number 7 looked like this. It says graph the equation of the line using the slope and y-intercept. And the equation they gave us was 2y minus 5x equals -20. And they want us to graph it, and they specifically said using the slope and y-intercept. Remember, we had talked about 2 ways of graphing. One was to find the intercepts of the line, and one was by using the slope and the y-intercept. And they asked us specifically on this one to use the slope and the y-intercept, which means what we have to do is put it in what we call the y equals mx plus b form. When you have y equals, and the y is all alone, the y is isolated, and everything is on the other side, the number in front of the x turns out to be the slope of the line. The coefficient of the x is the slope. The number that doesn't have any x attached to it, the number that stands alone, is the b, that's the y-intercept. And if we know the slope and the y-intercept, then we can graph the line. So the first thing we have to do is put this in the right format. So first I bring the -5x to the other side by adding 5x to both sides. So this gives me 2y, this cancels out, and I have on this side a 5x and a -20. We put the x term first, so it's 5x minus 20. They're not like terms, so they can't be combined. And then to finish this off, to get y alone, to isolate the y, we divide everything by 2. So my equation comes out to be y equals 5 over 2x, and 20 divided by 2 minus 10. That's the equation of my line in y equals mx plus b form, slope intercept form. The m, which is the slope, is 5 over 2, because that's a number that's in front of the x. The b, which is the y-intercept, is the number that's standing alone, that's -10. So how do we graph this? Suppose this is my graph paper. Try not to go down too low. Here's my x-axis, here's my y-axis. When you're using the slope and y-intercept to graph a line, you start at the y-intercept. This is your starting point. Y-intercept is where the line is crossing the y-axis. So I have to go down 10 on this. 1, 2, 3, 4, 5, 6, 8, 9, 10. If you have graph paper, of course, it's easier to do. Here is your y-intercept. this is actually the point 0, -10. When you're talking about the y-intercept, the x has to be 0 because it's on the y-axis. -10 is what we see from the equation. The next thing we have to do is look at the slope. The slope is 5/2. That means, remember, slope is rise over run, which means in this case, we'll rise 5 and we'll run 2. So where do we start from? From this y-intercept. From there I go up 5. 1, 2, 3, 4, 5. Run 2. Run means go to the right. 1, 2. Here's a second point on the line. I can then use this, start from this point, this new point, and do this again. I can again rise 5. 1, 2, 3, 4, 5. Run 2. 1, 2. And if you notice these lines, since this is not a piece of graph paper, it doesn't come out exactly as a straight line, but this is your line. And here's the line that we graphed from the slope intercept. And basically that's where we had left off on Thursday. Now, does anybody want to ask me a question before I go on? Okay, so I'm going to erase this and I'm going to start with the new material that I want to talk about today. Number 1, we've been using this term slope a lot. So let's discuss really what does the slope tell us. Obviously, we said the slope tells us rise over run. Well, look at these two lines that I'm drawing here. Here's one line, and here's another line. And I tried to draw these lines so that they are parallel. What does it mean that lines are parallel? It means that the lines, no matter how far you extend them, will never meet. They're always the same amount apart, no matter where you are. You know, this doesn't look exactly parallel. Okay. Well, think about it in terms of the slope. Remember what the slope tells us. The slope tells us how much the line is slanted. That's why we use the word slope, like slope on a mountain. It's the slant of the mountain. That's what slope is telling us. So if you look at it, these two lines, they're not the same line, but they're slanted the exact same amount. And therefore, it turns out that when we have parallel lines, the slopes are exactly the same. The slopes are equal. In other words, if I were to tell you the slope of this line is 2/3, if I could figure that out, and I told you this line is parallel to it, then the slope over here would also have to be 2/3. As a matter of fact, if you have the equations of two lines, you can tell if these two lines are parallel without drawing them at all. All you have to do is figure out the slope from the equation, and then if they're both the exact same number, or let's say one is 3/4 and one is 6/8, which obviously if you reduce 6/8, you can get 3/4. These two lines, a line whose slope is 3/4 and the line whose slope is 6/8, would be parallel lines. There's another thing we can tell from parallel lines, from slopes, from slopes. Okay, look at these two lines. Suppose, here's my graph paper. Suppose I have one line that goes like this, and one line that goes like this. The two lines are obviously not parallel because they're meeting, they're intersecting lines, but they're intersecting in a specific way. If you see, they're meeting at what we call square corners. Put a little square over here. Those they're meeting at right angles, 90-degree angles. Those lines are called perpendicular. So perpendicular lines are lines that intersect at 90-degree angles. And if you look around your room, you'll see there are lots of places you see perpendicular lines. Look at the corners of this, I don't know if you can see it, the corners of the board that are meeting at right angles. These are the two ends of the board are perpendicular lines. It turns out that you can tell that lines are perpendicular from their slopes as well. Obviously, the slopes are not going to be the same number because then the lines would be parallel, and they're not, they're perpendicular. So what's the rule? Well, let me give you an example. Let's say the slope of this line is 3/4. Suppose I tell you the slope of that line is 3/4. Then the slope of this line would have to be -4/3. What have I done? I flipped the fraction. Remember, slope is always a fraction. If it's whole number, it's over 1. Flip it and switch its sign, and you will get the slope of the line that's perpendicular to it. That's what we say the slopes are opposite, or sometimes the word negative, opposite reciprocals. The word reciprocal means you have a fraction and you flipped it over. Opposite means you switched its sign. So sometimes they use the term negative reciprocal. Again, that means you switch the sign. Or more descriptive, I think, is, that's why I put this in parentheses and I called it opposite reciprocals. I'm just using this because sometimes that's what you'll see in a textbook or you may have heard. In other words, if I tell you the slope of one line is -2, and I ask you what would be the slope of the line that's perpendicular to this? Well, -2 really is -2/1 because any whole number is over 1. Then its negative reciprocal or opposite reciprocal would be +1/2. You flip over the fraction and you switch its sign. Since the original was negative, the other one is going to be positive. That makes sense if you think about it, because if one line goes this way, in other words, it has a positive slope, the perpendicular line will have to go this way and have a negative slope. So these two facts will tell you if lines are parallel, they'll have the same slopes, and if they're perpendicular, then their slopes will be opposite reciprocals. The fact that when they're parallel lines that they have the same slope sort of makes sense. This is something you're just going to have to accept. It is something that's provable, but you'd have to know a lot more math for me to prove this to you. So you're just going to have to take it on faith now. Okay, now, first of all, what does that mean? Well, here's one type of question you might be asked. suppose I tell you I have one equation here's the equation of a first line. 3x plus 4y equals 6. And my second line is 8y minus 6x equals 60. Here are two linear equations. I know they both happen to be not in y equals mx plus b form. They're both in what we call standard form, x, y equals a number. They're equations of two different lines. I want to find out if these two lines are either parallel or perpendicular, or maybe neither. And the only way I can do that is if I look at the slopes of those lines. They'll be parallel if the two slopes are the same number. They'll be perpendicular if the slopes are negative or opposite reciprocals of each other. And if they're neither the same nor opposite reciprocals, then they're just two regular lines that happen to be not parallel and not perpendicular. They're just two lines that meet at random, not at right angles. So in order to do this, what we have to do is find out the slope of the lines. And the way we find the slope of a line from the equation of the line is we put it in the slope intercept, the y equals mx plus b form, and look at the number in front of the x. So here's number 1. I'm going to put that in the slope intercept form. So this is going to be 3x plus 4y equals 6. Bring the 3x to the other side. This will give me 4y equals negative 3x plus 6. And then I'll divide by 4. And when I simplify this, I get y equals negative 3/4 x plus, and this I can reduce to 3/2 because both the top and the bottom can be divided by 2. Which means for this particular example, the slope of the line is negative 3/4 because that's the number in front of the x, the coefficient of the x. The b, the y-intercept, happens to be 3/2. Now, I really don't care about the y-intercept. What I need to know is what is the slope. The slope of line number 1 is negative 3/4. We found it by putting it in the y equals mx plus b form. Okay, let's look at line number 2. Line number 2 looks like this. I have 8y minus 6x equals 16. Again, I have to get the y alone. So therefore, I have to bring the x to the other side. So I'm going to do plus 6x to both sides. So this gives me 8y equals 6x plus 16. And I'm going to divide everything by 8. And therefore, I'm going to go over here because I don't want to go too low. I get y equals 6/8x plus 16/8. And these fractions can be reduced. So this really gives me y equals 6/8. I can divide both by 2. I get 3/4x. And 16/8 just becomes 2. So for this particular example, the slope is 3/4. and the y-intercept is 2. Now again, what am I interested in? I'm interested in the slope because I want to know if the lines are parallel, perpendicular, or neither. So I just look at the slope. The slope here is 3/4. And I compare these two slopes. Are they the same? They look almost the same, but this is -3/4 and this is +3/4. They have to be identical, same number, same sign. No, they're not the same. No, the lines are not parallel. Are the slopes opposite reciprocals? Well, they certainly have opposite signs, but they both are 3/4. In order for them to be opposite reciprocals, if this would be -3/4, this would have had to be +4/3. So they're not opposite reciprocals. So they're neither parallel nor perpendicular. They're just regular intersecting lines. Neither parallel nor perpendicular. That's two regular old-fashioned lines. Regular intersecting, not parallel, not perpendicular. Okay, I'm going to give you I'm going to do some more problems, and then I will stop and I will give you time to do a bunch of problems in your groups, and I'm going to then ask the groups. I'm going to try to finish the groups, get to groups early, so that at the end of the period we can have each of the groups do one of the problems. I hope everybody has their practice sheet 2 with them, because I'm going to assign the groups the different problems in that, on that sheet. Okay, so let's try another problem. What we're going to be working on here is how do we write an equation of a line. I'm going to describe a line to you with certain characteristics, and from those characteristics we're going to get to the equation of the line. This is just the opposite of what we were doing until now. Beginning of the class, what we did is I gave you the equation of the line. I said, draw the line. Now I'm giving you a description of the line. In other words, I'm telling you what the picture of the line looks like. Can you write the equation of the line? So let's start with something like this. Suppose I give you a line that has a slope of 2 and goes through the point 1, -3. This is where I'm giving you a point and a slope of the line. Can you tell me what the equation of the line is going to be? Okay, so I'm going to do a few different questions of this type, where I'm going to describe a line to you, and then we're going to write the equation. Basically, what we're going to be getting to is y equals mx plus b. We're going to fill in the particular m, the slope, and the b, the y-intercept. And then we will have the equation of our line. Now, whenever I want to do that, the first thing I always want to concentrate on, what I want to work on, is what is the slope of the line. Now, sometimes they give us the slope, or sometimes they make us figure out the slope. For this particular equation, they told us the slope is 2. So if I fill that in, I know for my line, it's going to be y equals 2x, my slope is 2, plus b. What I don't know is the y-intercept. I now have to find the y-intercept. Now I can't say the y-intercept is -3 because the only time I have a y-intercept is if the first number, the x number, is 0, then the second number is where it's crossing the y-axis. The y-intercept is where it's crossing the y-axis. But you can always figure this out. Just want to get a different colored using a red. In order for this point to be on the line, when I stick in the coordinates of the point, the x and the y, the points, it's going to make the equation work out. That is the relationship between points on a line and the equation of the line. The points work in the equation. That means if I replace the x with 1 and the y with -3, then I'm going to get a true statement. That means -3, that's my y, is going to be 2 times 1, which is 2, plus b. Now remember, I still don't know what the b is, but now I can figure out what the b is by getting the 2 to the other side. So if I do that, it turns out that b equals -5. And therefore, in order for this point to be on the line, on this line, my equation should be y equals 2x, my slope is 2, minus 5, because I've worked out the fact that the y-intercept is -5. Notice I didn't even draw the line. I can tell by looking at the information that they gave me. So every time I'm going to be looking to find the equation of a line, I'm going to be looking to write the y equals mx plus b form of the line. I will first work on what the slope is. In this case, it happened to be easy because they told me what the slope is. And then after I find this, put in the slope, I then work on finding the b by taking a point and sticking its values into the equation. Does anybody have a question about this before I try another example? Okay, so let's try another example. I'm leaving this y equals mx plus b on the board because we need to, we will be using it again. Here is another question. This is question number 11 on this exercise practice example sheet 2. It says, write the slope-intercept equation for a line with the given characteristics. It passes through the point 5, -6, and 2, -4. Remember, once you tell what 2 points of the line are, that really determines what the line looks like, because the line has to go through these 2 points. So you could really draw this line. Again, what we're aiming for is to write the equation of the line through these 2 points. Again, we want to get something in, they said the slope intercept, the y equals mx plus b. And in all these cases, you want to first figure out what the slope of the line is going to be. Well, when you have 2 points, you can find the slope of the line by using what we call the slope formula. y2 minus y1 over x2 minus x1. Again, I'll arbitrarily pick this to be my x1, y1. That'll make this one the x2, y2. We did this before. You pick one point to be your first point, then you go to the next one, and that's your second point. Okay, so let's see. y2 is -4 minus y1, so it's minus -6. Is y2 minus y1 over x2. Remember, always do them in the correct order. The x2 is connected to the y2. So x2 would be 2 minus x1, which is 5. Make sure, I always like to write this out. I like to write out so I don't mix up. I don't mix up the x's, I don't mix up the y's, and I have everything in order. Remember, when you have 2 minuses, this is going to become a plus. So this, the numerator becomes -4 plus 6 over 2 minus 5. And -4 plus 6 is +2. And 2 minus 5 is -3. My slope is -2/3. Usually when the negative comes out in the denominator, I just put it in the front or on top. It's easier to work. A negative in a fraction can be located in any one of 3 places. It could be in the numerator. So it would be -2/3. It could be in the denominator. It could be 2 over -3. Or it could be just in front of the fraction itself. These all mean the same thing. It doesn't matter where your negative is. Don't put 2 negatives. If there are 2 negatives, a negative and a negative, then it just becomes positive. Okay, so we've accomplished the first thing that we need to know for our equation. We now know that our slope is -2/3. So my equation is going to be y equals -2/3 x plus b. I still don't know what the b is going to be. I don't know what the y-intercept is here. That's where I have to go to either one of these points. And it doesn't matter which one you pick. Let's pick the first one and substitute the coordinates, the numbers, into the equation. Okay, so we're going to replace the y with -6 and the x with 5. Now we're going to have to be careful because there are going to be fractions here. This is -6 equals, okay, so now we have to do -2/3 times 5, which I'll write as 5/1. As a matter of fact, let's put everything over 1 so that we can tell when we have fractions, it's easier to put the whole numbers over 1, and then you can see what's in the numerator, what's on top, and what's on the bottom. Okay, so this becomes -6/1. Now I have to multiply this. -2/3 times 5/1. Now there's nothing that we can cross cancel, so we just multiply the numerators together. -2 times 5 is -10. over 3 plus b over 1. And if you recall, we said one way, it's not the only way to do it, but it's one way we could do it, is by multiplying everything by the common denominator. Look at the denominators. I have a 1, a 3, and a 1. If I multiply them all together, 1 times 3 times 1, that gives me 3. My common denominator is 3. I put 3 over 1, and I multiply it by the whole equation. Now, I'm going to have to erase some of this. Anybody still needs it? Okay, so I'm going to erase this so that I can have room to work. Okay, let me just put this on the side. We were working on, my equation at this point was y equals negative 2/3 plus b. And we're 2/3 x plus b. We're looking to find the b. Okay, so I'm over here. I'm going up here. Multiplying, this is going to be 3 over 1 times negative 6 over 1. Remember, I'm distributing this 3 times 3 over 1 times negative 10 over 3 plus 3 over 1 times b over 1. I just multiplied every single term by the 3 over 1. Okay, here nothing cancels out because the two denominators are 1, and I just have 3 times negative 6, which is negative 18, is negative 18 over 1, so I could just write it as negative 18. That equals, okay, here we have a 3 in the denominator. It's going to cancel out with this 3 in the numerator. These are going to be 1s then, and I'm just going to have 1 times negative 10, which is negative 10 over 1, which is just negative 10. And finally, here again, nothing cancels out, so it's just 3 times b, which is 3b. To finish this up, I'll just add 10 to both sides. This will be negative 18 plus 10, which is negative 8. And this cancels out, and this gives me 3b. And I'll divide by 3. And here it turns out that my b is negative 8 over 3. If I had used the point 2, negative 4, I would have gotten the exact same answer. It doesn't matter which point you use. So the equation of my line is y equals negative 2/3 x, and my b is minus 8 over 3. And here's the equation of the line in y equals mx plus b form. So we've started with 2 points, any 2 points, and we found the slope, and then we found the y-intercept to give us the equation of the line. Okay, any questions about this? Okay, I did not take attendance yet. I will take attendance just before we go into the breakout rooms. Okay, I want to do another equation, another example before we break up. Okay, I am looking at question number 15. Determine the equation of the line described. Put the answer in slope-intercept form. In other words, in the y equals mx plus b form. And here's the description of the line. We're told that the line goes through the
attendance count, please.
What? Excuse me? Question? Okay. We're told that the point goes through the point -7, 0, and it's perpendicular to the line 7x plus 9y equals 18. And we want to write the line that will pass through the point -7, 0 and be perpendicular to this line. And remember, when I want to write the equation of the line, the first thing I concentrate on is what is the slope of the line. And they didn't tell me the slope this time. The only thing is they gave us a hint. They said it would be perpendicular to this line. And if we recall, when we started this class, we said we can tell when lines are perpendicular and parallel by looking at their slopes. Parallel lines have the same slope, and perpendicular lines have slopes that are opposite reciprocals. In other words, if I can figure out the slope of this original line, I'll call this line 1. If I find the slope of this original line, line 1, then it'll give me a hint as to what the slope of my line is going to be. I'm going to call my line line 2. So what I have to do is put this line in the y equals mx plus b form, so I can see the slope by looking at the number in front of the x, the coefficient of the x. So first bring the 7 to the other, the 7x to the other side. So this will give me 9y equals -7x plus 18. And then I'll divide everything by 9. So in y equals mx plus b form, my line number 1 is -7 over 9x, and 18 over 9 is 2. Now what we're interested in is the slope of this line. What is the slope of this line? I hope you can see that. The slope of the line is -7 over 9. That's the slope of line 1. Because that's the number that's in front of the x. So for line 2, the line that we're interested in writing, I know what its slope is going to be. In order for it to be perpendicular, its slope has to be the opposite reciprocal. So the slope of line 2 has to be +9 over 7. It has to be flipped over and switch signs. So when I go to write the equation of line 2, the line that I'm really interested in finding the equation of, my equation is going to be y equals m. Well, the m is 9 over 7 x plus b. In other words, we had to do all this work over here to find the slope of the original line, so I could flip it over and switch its sign to get the slope of my line. And now we do what we did before. We take a point, and we only have one point, so we have to take that point and stick it into the equation. In place of the x, I'm going to put -7. In place of the y, I'm going to put 0. So this equation is going to become 0 equals 9/7 times -7, which I'll put over 1 so I just keep track that the 7 is in the numerator, plus b. And here the 7's happen to cancel out. This becomes a -1. So this becomes 0 equals 9 times -1, which is -9 plus b. And to get the b alone, I'll add 9 to both sides. And therefore, I'll get b equals 9. So the equation of the line that I'm looking for is my slope is 9/7. My y-intercept is 9. So in my equation, the answer to this question is y equals 9/7 x plus 9. So if they had told me the lines were parallel instead of perpendicular, I would just have used the slope here, -7/9. So notice, giving a description of the line allows me to write the equation of the line. Okay. Before, I'm going to give you on these sheets, we have about 45 minutes left. I'm going to give you 5 problems to do in the 45 minutes. You can get started now, and then I'm going to break you up into after I take attendance, I'm going to break you up into the breakout rooms, and you're going to work on those 5 examples. And after that, I'm going to stop the class, and I'm going to have everybody, each group have one presenter of a problem. Okay, so here are the 5 problems I would like you to do. You write these on the board. Numbers 9, 10, 14, 17, and 19. Okay, so these are the 5 problems you're going to be working on in your groups. Let me erase this now. And I'm going to stop the recording. And I'm going to take attendance. You can start working on these examples now. And when you go into your groups, I'm going to tell each group which examples I want them to do. I'm going to break you up into 5 groups. Okay, so first while you're working on this, let's look at the attendance. Ray, are you here, Ray?
Yeah, I'm here.
Okay. Lukey.
Hey, I'm here.
Okay.